Welcome back, students. We are moving to the problem number 2 of drawing number 11. The problem number is 3.2. The problems 3.2 and 3.3 are on simple position 2 in projection of prisms. So we will go back to those 4 question and answers once again. So I have written on my sheet here. Let me explain simple position 2 here. Let us come to the sheet here. So just like in projection of planes, even in projection of solids, here SP2, what is SP2 is the first question. A prism resting with its base on HP, but one of its base corners will be on the right side. In simple position 1, one of the base edges was on the right side. We took it perpendicular to VP. Here we will be taking one of the base corners on the right side. When I demonstrate in the problem, you will understand it better. Now, when to adopt SP2? When the prism is resting with one of its base corners on HP, that is condition 1. Condition 2 is either base is inclined to HP at theta, or axis is inclined to HP at theta, or longer edge containing that corner is inclined to HP at theta. Let me show it in the box once again here. This is a rectangular prism. So we took it like this. In the last step, it was resting like this. The base edge was on HP. Now it is going to rest only about the corner, or just one corner will be there on HP, like this. It is resting with just one corner on HP, this base corner. So this position may be mentioned by giving any one of the angles. Inclination of the base, inclination of the axis, or inclination of this longer edge also can be given. Okay, I repeat once again, it is just resting with a corner on HP, and this position can be specified by giving any one of the angles. Inclination of the base with HP, inclination of the axis with HP, or inclination of this longer edge with HP. Okay. Yeah, let me come back to the sheet here once again. So when to adopt SP2 is the question, when this is the condition in the problem, and the prism is resting with one of its base corners on HP, with base inclined to HP, or axis inclined to HP, or longer edge containing that corner inclined to HP. This is SP2. Now, how to start in SP2? Here also, just like in projection of planes, we start by drawing the top view first. Of course, we take one of the base corners on the right side instead of edge. How to proceed? This is a chain, SP2, HPC and VPC. So it is almost similar to what you had in projection of planes. Okay. Rules of visibility will be the same. Whatever we have applied in problem number 1 will also be applicable for any problem on projection of prisms. So let me start by doing the problem number 3.2. We will complete this problem into two parts, part 1 and part 2. Okay, let me start. This is a problem on hexagonal prism. 25 mm is edge of base, 50 mm is axis length. Okay, so this is a hexagon. This is your XY line. It's a hexagon. You start by drawing the hexagon in the top view. Corner should come on the right side. That's what you should make sure. Yes, I have drawn the hexagon in the top view. I'll start by naming the corner here. A, B, C, D, E, F. This is the top face of the prism which is visible to the observer, so I have used solid lines. Now beneath this you have the base which is not visible to the observer. So A1, B1, C1, D1, E1, F1. In fact, you should connect all those A1, B1, C1, D1, E1, F1 by dotted lines. But because the dotted lines coincide with the solid lines, you cannot show in the top view. Okay. Done. Now let me mark the dimension for this edge. The edge length is 25. Let me obtain the center to mark the axis in the top view. So these lines are light lines. I got the center here. I will mark it as O01. This is the axis which appears to be a point in the top view. Now I am drawing the front view. This is where you have the base. Base is on HP. This is the position of the observer. D dash. C visible. E invisible. In other words, C1 dash. E1 dash. B1 visible. F1 invisible. B1 dash. F1 dash. A1 dash. Let me project the axis also. This is O1 dash. Now I am going to take the height as 50. This is 50 mm. Let me complete the front view. Axis will be drawn as a chain line, that's a thin line. You can mark the points. This is D1 dash. This is D dash, C dash, E dash, O dash, B dash, F dash, and A dash. Show the dimension. The height is 50. This is your SP3. Simple position 3. Now we are going to satisfy HP condition in the next step. The HP condition says the axis of the prism is inclined to HP at 40 degrees. This is the axis. So keeping the corner A1 on HP, you are going to rotate the prism in clockwise sense. Okay. So I will start by drawing this edge first at 40 degrees to XY line, so that axis also will automatically come inclined at 40 degrees. I am drawing a line inclined at 40 degrees here. I will start with A1 dash, draw the line inclined at 40 degrees. Okay. This length should be equal to 50 mm. Now I will draw the base. The base should be perpendicular to this edge. And then I will complete the rectangle. Same dimensions, no change in dimensions. Now let me mark the points from here to here. It's B1 dash, F1 dash. Then comes O1 dash. This is C1 dash, E1 dash. This is D1 dash. The lines will be drawn as they are in the first step. This is A dash, B dash, F dash, O dash, C dash, E dash, and then D dash. Now when you are showing the inclination, you should show the inclination of the axis as 40 degrees. This is the front view. Now let me complete the top view also in the second step, and then we will stop there and move to part 2. Now this is the position of the observer. This is the top face that is nearer to the observer, so that should be drawn visible. I have projected all those points. Now let me draw the locus lines. name all the points and draw all the lines as solid lines, continuous lines. There will be 6 lines here. This is the top face, which will have 6 edges. So this is A, B, C, D, E and F. The top face is visible to the observer, so I am making all the 6 edges solid lines. This is the top face. Now what is the next step? You should project the remaining 6 points of the base and identify the boundary. I am following the rules of visibility one by one. Let me mark these points. This is A1, B1, C1, D1, E1, F1. You can easily identify the boundary. This is the boundary. So what does the rule of visibility 3 says? For the base which is away from the observer, all the lines are not visible. The lines that coincide with the boundary are visible. Now what are all the edges here? F1 E1, E1 D1, D1 C1, C1 B1, okay, B1 A1 and A1 F1. Now B1 A1, this is A1. B1 A1 and A1 F1 are inner lines. They are not coinciding with the boundary. So the rule says they are invisible. So I am making them dotted. Yes. Now let us come to the connections. The connections of the inner lines. Here you have ED and DC as solid lines. They are inner lines. What is the connection for them? D11 is the connection. So I will make D11 solid. Now what is the other set of inner lines that you have? F1 A1 and A1 B1. They are dotted. And what's the connection for them? A1A is the connection. So A1 to A should be dotted line. But already this A1 to D is there as solid. So you cannot show that as dotted. Whatever is remaining can be shown as dotted line. So dotted line will be shown only from D to A. Have you understood this point? This point D. A1 to A in fact is dotted line, but A1 to D is overlapped by a solid line, so you cannot show it as a dotted line. Only this portion can be shown as dotted. And then finally you can represent the axis. This is the point O. This point is O1. Even axis cannot be shown here. It is overlapped by other lines. So in this line there are 3 lines, one coinciding with the other. One is the line DD1. You also have AA1. You also have the axis OO1. They are all in the same line. They are one below the other. So only one edge is visible to you, DD1. AA1 is invisible. Axis is also in the same line. Axis is an imaginary line. So you cannot show it as visible or invisible anytime. Okay, it's always an invisible line. So this is the second step where you satisfied HP condition. We'll break here and come back for the third step.